Hello and welcome. Thank you for joining me as I go about solving problems related to the operation of electrolytic cells. On the board, we are given a diagram which represents an electrolytic cell that is meant to purify copper. We've got electrode R, which is the anode, and electrode T, which is the cathode. And we're told that a constant current is registered on the ammeter and 1,72 grams of the copper is deposited on the cathode in 30 minutes. The instruction says calculate the reading on the ammeter. Okay, firstly we need to make sure that we know the half reaction which occurs at electrode R. It should actually be this. This is the half reaction which occurs at electrode R. Bear in mind that at the anode, that is where oxidation occurs. Now we are told that there is a constant current of which actually is registered on the ammeter, and 1,72 grams of the copper is deposited on the cathode, meaning that the mass of the copper is 1,72 grams, and the change in time is 30 minutes. In 30 minutes, we've got about 30 by 60. 30 by 60. That translates to 1,800 seconds. Okay, what else do we have? The instruction says calculate the reading on the ammeter. In other words, we are required to determine the current which flows through the ammeter. The manner in which we should go about doing that, we actually have to find out the charge. The charge that flows from this electrode to that electrode. We're given this mass. Okay, let's use this mass to determine the number of moles pertaining to copper. Okay, we'll have 1,72 divided by the relative atomic mass of copper is 63,55. Then you'll take 1,72 and divide it by 63,55 to get 0,027 moles. That is the number of moles of copper which is deposited on the cathode. Okay. From this equation representing the half reaction, we can see that each carbon atom releases 2 electrons. Therefore, we have to come over here and check the number of electrons that are released. Okay, we'll have to approach this via determining the number of moles pertaining to the electrons that are released. And we'll get the mole ratio is 1:2. The mole ratio is 1:2, meaning that for that number of moles of copper, we're going to have twice that number as far as the electrons are concerned. Then to give us 0,054 moles. So this is the number of moles pertaining to the electrons which are released. Now we are concerned about the charge. We need to determine the charge that actually flows from electrode R to electrode T. The manner in which we go about determining the charge, bear in mind that as far as the number of electrons are concerned, we're going to have this, N being equal to N over Na, which is Avogadro's number. The number of electrons that are released will be this, 0,054 by 6,02 by 10 to exponent 23. Okay, 0,054 by 6,02 by 10 to exponent 23. 0,054 by 6,02 then to 3. Here we get 3,2508 by 10 to exponent 22. That's the number of electrons which are released from the anode and they move to the cathode. Okay, now that we have the number of electrons that are released, we have to determine the charge of these electrons. So we're going to use this. Use this formula and you substitute accordingly. 508 by 10 to exponent 22. This will be equal to Q divided by the charge on an electron. 10 to exponent negative 19. So the total charge, obviously, electrons have got a negative charge, but because we want to go somewhere, we'll just use the size of the charge. The size of the charge. 1,6 by 10 to exponent negative 19 by 3,2508 by 10 to exponent 22. So it means that the charge which is released by this total number of electrons is 5,201,28 coulombs. Bear in mind that our main aim is to find out what the current which flows through that ammeter is. Okay, on reaching this point, you can make use of this formula. Q is equal to I delta T to determine the current. That's the charge over there. The 5,201,28 all divided by the time taken, 30 minutes, which give us 1,800 seconds. 1,800 seconds. So just divide the number of charge by the number of seconds. And we get 2,89 amperes. That is the answer. Basically, in short, this is how we go about working on problems of this nature. I hope you have learned something from this. Thank you very much for spending some time with me. And for more information, please subscribe to our YouTube channel at PP Maths and Science Lab. Thank you.